All right, welcome back. So, this is a quick walkthrough on this still kind of objective here in 8.6 and 8.5 really. I would say more so the 8.5, because 8.5's learning objective was this basically, how to determine the limiting reactant and calculate theoretical yields, actual yields, and percent yields. And then 8.6 was just adding in the fact that you could do it with terms of mass. Okay, but really this lab, a simulation, hands-on experience, if you will, is going to be all in terms of moles. You're not really going to be dealing with grams. And so let me show you the website you're going to be using. You guys are mostly familiar with it. You used it before, but I want to show you the simulation, and I kind of want to use some of the stuff that you're not going to have to do on this. I'll use it myself as a way to teach you. So here you go, reactants, products, and leftovers. Instead of making pancakes, we're going to make sandwiches this time. And so this is really cool. You can look at the top, there's settings there for cheese, meat and cheese, or a custom sandwich. We can do, because see, if you just do meat and cheese, there's the recipe. You see the recipe there? It's 2 pieces of bread, obviously, duh, 1 meat and 1 cheese. Okay, but you can make a custom sandwich. Like sometimes I like to make a 3 bread sandwich with like a piece of meat in between each layer of breads, so it's almost like 2 sandwiches in one. But instead of eating 2 sandwiches, you kind of like got like a 1.5 and 1.5, I guess. Or I mean, you got like a instead of 4 pieces of bread, you got 3. And so if that was the case, you would want to put a piece of meat probably between each 2 breads, and so that's why I put 2 pieces of meat there. And you could do 2 cheeses as well. But if you wanted to go a little overboard, you could have 4 or 3 pieces of cheese, and you could even have 3 pieces of meat, or you could just do 1 piece of meat and 1 piece of cheese, but yet extra bread. So you can adjust the recipe to how you like, which is kind of cool. But let's keep it to meat and cheese, and let's look at this recipe here. Just 2 pieces of bread, 1 meat and 1 cheese. Now there's nothing really you can calculate or do here. It allows you to play with it. So like, let's say I bought a whole loaf of bread, and I obviously ate some out of it, and so I had most of it, which is 8 slices. That 8 slices of bread, that's quite a lot. Let's say I only had a few pieces of meat left, and only a couple cheeses, only like 3 pieces of cheese. How many sandwiches could I make? Well, you'd only be able to make 3 sandwiches, and you'd have 2 pieces of bread left over, and you'd have 2 pieces of meat left over. Now, you could totally do the calculations, or you could simply just do the counting, right? And so I love how this allows you to kind of count. And you can play with this a little bit. Like, if we reduce the amount of bread, do we mess up our sandwich count? No, we still make 3 sandwiches. We could even bring down the meats, right? So there you go. We got perfect 3 sandwiches. And so what if we had less bread though? You took away just 1 piece of bread. Now all of a sudden we got all this extra meat and cheese left over, and even a piece of bread, because it requires 2 for each sandwich. Take away another piece of bread, and we still have 2 sandwiches. We didn't make any extra meat left over. It's only when you lose a sandwich that you start gaining excess meat and excess cheese. All right, so moving on from that, let's look at molecules. You can kind of do the same thing here. You see the recipe up top. Super, super basic. Making water. Let's do something a little more interesting. We already did that reaction, and we've done the making ammonia. I think we just did that in the lesson. How about combusting methane? So this is the natural gas that comes out of the pipes usually. Like in our lab, it's methane gas. It's hydrocarbon, one of the most smallest, lightweight, 1-carbon hydrocarbons. But it's combustible still. And if you put it in the presence of oxygen and you burn it, you're going to get CO2 and water. Remember combustion reactions? You always get CO2 and water in just different amounts. Well, what if we had like 5 methane molecules there? How many oxygen molecules would we need? We would need a lot, wouldn't we? Let's look to the right. I'm going to keep adding them on the left, and then look to the right to see when all the methanes are finally going to disappear. I can't even add any more. It's only allowing me to add 8. So you can see it takes a lot of oxygen even to burn methane. So let's reduce the methane a little bit to 4 and go back down to 5 oxygens, and then increase the oxygens until the methanes finally go away. There you go. It would take 8 oxygen molecules to react with 4 methanes. Let's take it down to 1 methane and have tons of oxygen in the air. What's going to happen? Well, we're going to end up making 2 molecules of water and 1 molecule of carbon dioxide, and we're going to have 6 molecules of oxygen left over. And we can keep reducing the oxygen count, and you see it doesn't change anything. It just makes less excess oxygen. But at some point, like right here, you can see just making that change right there says that it's not even going to combust anymore. You can put methane in the presence of oxygen, but if you only put it 1 methane molecule in the presence of 1 oxygen molecule, you just simply won't have a reaction. Everything is a leftover. So you see that stuff over there on the right, how there's a little bracket that says leftovers? That means it's basically a reactant that's not going to react. It's not going to become a product, really. It's just a leftover. Okay, so you're going to go to the game. You're going to do all 3 levels. Make sure you look at all the settings, like you can hide molecules. You can hide numbers. Basically, I want you to show all. Don't hide anything. Show it all. And you're going to do level 1, which has 5 problems. Okay. You're going to do level 2, which has 5 problems. These are real simple equations too, by the way. And level 3. Okay. So when you get 5 stars on all 3 levels, screenshot it. Do you see how you can tell it's 9/24? It's Wednesday, April 8th, and that I have 24% battery life and barely a Wi-Fi signal. Make sure when you screenshot, you get that whole page, so I don't see anybody with the same 2 pages. If I get suspicious, I will just tell you to resubmit another picture until it doesn't look like someone else's. So don't crop your image to show just the levels. Okay, I'm wiser than that. So please make sure your screenshots look different, whether you're doing it on your phone or desktop. It should be real obvious that your picture is unique from someone else. That is going to be a lab. It'll be worth 15 points, 5 points per level. So 5 points per 5 stars. Okay, if you only get 4 stars, that's okay. It shouldn't hurt your grade too much. Okay, that is going to be it for that quick tutorial on your lab. I'm about to film your 8.3 video to get that sandwiched in between since I missed it. And then I'm going to be done for the evening, and I'll only have one more video, the enthalpy of chemical reactions. It's sort of out of context, but not really. It still has to do with quantities and chemical reactions. In other words, we'll be using the recipe still, but that one section, I'll just probably film that at like the end of next week or something like that, because I have plenty of time. So you got enough to chew on for a while. Adios.